Today we are in Humper, California. We are at a field day to demonstrate the drag hose technology. This dairy has approximately 1,200 milk cows which are bedded on mattresses with no additional bedding. The manure is removed from the barn with a scraper system and pumped to a wastewater storage which is approximately 600 feet away. The slurry is highly concentrated material since there's no addition of wash water from the milking parlor. The content of the slurry is approximately 9% solids with a nutrient level averaging 45 pounds of nitrogen per 1,000 gallons. At the wastewater storage, there is a high-pressure pump which is pushing the manure slurry through a 6-inch hose to a field 1.5 miles away. Drag hose technology has been used for a number of years for transferring manure from confined animal feeding operations. This technology allows for the injection of manure to remote forage production fields at precision rates. To date, this technology has not been widely utilized in California. This USDA-funded demonstration project is intended to provide exposure of the technology to innovative dairy operators in the San Joaquin Valley.
Today we're pumping manure from the dairy, which is over about 1.25 miles away, and we're pumping through a 6-inch hose, and then we're dragging a 5-inch hose behind a tillage tool, which is applying the manure directly to the soil. The application rate is 10,000 gallons per acre, and how we control that is there is a mag meter on the toolbar which measures the gallons per minute, and then the operator will operate the tractor at the proper speed to give the accurate application per acre. The manure that we're pumping today is about 9% solid. It's a scraper barn so that the manure has no bedding in it, but it is very thick. It's up to 9% in solid content. The nitrogen level is 45 pounds per 1,000 gallons, and that's the reason why we're applying 10,000 gallons per acre. The tillage tool is a minimum till unit, which is very popular in areas where they have to practice minimum till. The equipment has the capability of pumping up to 2 miles with one pump. If we add an additional pump, we can pump 3 or 4 miles. Typical application with a hose drag system is going to be in that 2 to 3 mile range or less. Obviously, as you travel further away from the source, we have to either add a pump or our volume per gallon will drop because of the friction loss in the hose. Typical mainline hose is going to be 6-inch, but we also have an 8-inch mainline, which will help you with your friction loss and let you pump a further distance without an additional booster pump. At the 1,300 gallons a minute that we're pumping, he's traveling approximately 2.6 miles an hour. The toolbar is 24 feet wide. The applicators are 2 foot on center. And as I said, it's a minimum till type applicator.
I'm the project manager for Dairy Central, the dairy owned and managed by Bob Borba. We primarily work with dairies in the Central Valley to write nutrient and waste management plans. We also help them comply with the record-keeping requirements of the general order that was passed in May 2007. One of the requirements is on a per-field basis to only apply at 1.4 times crop removal. So if a crop were to remove 100 pounds of nitrogen, you're only to apply at 140 pounds of nitrogen. Well, controlling the amount of nitrogen that goes on in the form of solid manure or wastewater is a challenge for a lot of producers, especially in flood irrigation systems, and that is one advantage when you have a system where you can direct inject. You've got meters, pump output, you can have concentration,
exactly right.
known concentration of the material that is going out.
So basically every square inch of every parcel whether it be 20 acres or 90-acre parcels. Yes, we know exactly what we're doing per acre. We tried the slurry tanks, and that just didn't seem efficient between the time, the fuel, the compaction. So we came across that drag hose idea from back in the Midwest, basically Midwest Europe, and we tried it here a couple months ago, and hey, it was much more efficient. And yeah, we were down on compaction, down on fuel, down on labor compared to the tanks, and so far we see some positive results. But that was a big plus. Since day one we've been concerned over the idea of putting so much material in its solid form in these ponds, as far as how are we going to get it out.
What Bobby has done here is really minimized a lot of the requirements for handling. On a scrape system, the manure is scraped directly from the free stalls into a pit and then is agitated and pumped out into a storage. There's very minimal water use, one of the lowest water use dairies that I work with and within a large region. The nice thing about the slurry system is because it goes directly from the free stalls into the storage area, it's agitated, and through the use of technology, which has been well used in the Midwest but new to California, the direct injection with the drag hose, you can go up to 4 to 6 miles with pumping the slurry and direct inject so that you have minimal losses from evaporation, ammonia losses, which is what we want available to the crop. We can control the rate of application.
Not to mention the fossil fuel footprint. A lot less fuel that we're using to transport this stuff.
And you're also not spending, time and resources to take, diluted manure, separate it out, haul off separated solids, to maybe transport those to the field. It's a very minimal handling, and you look at that from an efficiency standpoint, and you just can't get much better than that.
Basically, we just direct injected, and had a lighter tractor, lighter implements. We didn't have the big heavy trucks out here, so less compaction. We came in, dissed it one time, ripped it one time, and irrigated. So we've saved tremendously on we figured about 40% as far as traffic, labor, tractor time, and so forth. And here we are, with a crop that hasn't asked for water up until now. Granted, the weather's been milder than last summer, these first few days of June, but we believe with that direct inject and lighter equipment over this driving over this soil, we got less compaction, so we absorb more moisture. We got a root system that just developed, vertically, basically.